Okay, so welcome, and this is your first lecture on a new topic, and that new topic is modern physics. Heard about modern physics?
No, sir.
No, you must have heard about it. You may not recollect it, but you must have heard about it. Do you know who I am? I mean, do you know my name?
Yes, sir. Astik, sir.
Good. Okay, then let us leave it at that. There is no point of me introducing myself. If you know my name, it's good. Modern physics. You must have heard about this. Have you heard about dual nature of particle, photoelectric effect, Einstein equation, all these things? Have you heard about them? Yes, sir. No, sir. Photoelectric effect. Have you heard about this photoelectric effect? Ever before? Photoelectric effect? No?
No, sir.
No? Strange. Okay, not a problem. That means it will take time. Photoelectric effect. Some on some metals, on some elements, when light falls, they start to eject electrons. Do you know that? You can call them
Sir.
photocells. Have you heard about photocells?
Yes, sir.
Photoelectric effect. So when light falls, current flows. In simple effect, you can call it as the photoelectric effect. You know the structure of an atom, right? An atom has a nucleus and it has electrons in the shells revolving around it, right? The electrons in the outermost shell, they are what? They are very loosely bound to the atom. Yes or no?
Yes,
Yes or
sir.
no?
Yes, sir.
If I can give them sufficient energy by whatever means, they can leave that shell and they can become free and they can freely move. Yes or no?
Yes, sir.
Now, how can you do that? How can you give energy to an electron that it leaves the shell? You can heat the metal, you can heat that atom. By heat, you can give it sufficient energy and it can leave that shell. Similarly, you can do it in a different way. You have electrons revolving in orbits. You can hit these electrons by a beam of electrons. Now this beam of electrons can also dislodge a electron from its shell. This is another way of making that electron free. Basically, we have to give it sufficient energy. Have you heard about the term ionization energy and this energy and that energy in chemistry?
Yes, sir.
Ionization energy. I want to break this electron up. I want to take this electron out and take it to infinity. By infinity, I mean that, I take it out of the atom. We call that energy as ionization energy. So somehow I have to give it energy. Now, have you heard that light is an electromagnetic wave? Yes or no?
Yes, sir.
Light has energy. Yes or no?
Yes, sir.
Now, if light has energy, if you allow light to fall on certain metals, elements, it may happen that this light has sufficient energy to liberate electrons from that atom. That effect is known as
Photoelectric effect.
photoelectric effect. Photo standing for light, electric standing for these atoms and current flowing. So this is known as photoelectric effect. Do you now get a sense of what is photoelectric effect? Right?
Yes, sir.
What we'll do now, since I understand we have very less time to, I have sent you a sheet which I am going to show you now. I've sent you this sheet already, and I hope that you will get it by today. I have sent it, so you should be able to get it by today. This is on the sheet. You see this part of the sheet. That is good enough. Photoelectric effect. So that is the heading. Will you be taking down notes or will you be just looking at the important things? There are two ways that you can do this. The important things, you can mark it on your sheet that you will get it. And the most important points or the most important formulae, you note it down in your notebook. Yes or no?
Yes,
This is
sir.
how you will go, because we don't have what?
Time.
We don't have enough time and we have to cover a lot of codes. Photoelectric effect introduction. What is photoelectric effect? So in simple terms, when radiation, what do we mean when I say radiation? When radiation, I mean light, basically. Any electromagnetic wave is a radiation. When radiation or light of suitable wavelength. Now, why this suitable wavelength? We will come to that. Or frequency. Why frequency? Again, we'll come to that. Or incident. Incident means when it falls on certain metals, electrons are ejected. Electrons get sufficient energy and they are ejected out. This effect is known as photoelectric effect. The electrons which are rejected are known as, not rejected, ejected are known as photoelectron. And if I can establish a current, this current is known as photoelectric current. Do we understand this in simple language?
Yes, sir.
Some important facts, you just need to remember it, because it may come as an objective question, whether in your boards or whatever. This was discovered by Hertz. Laws of photoelectric current was given by Leonard, and it was explained by Einstein, Sir Albert Einstein, by something known as quantum theory of light. Do you know what is quantum theory of light?
No,
You
sir.
might have heard light has dual nature. Do you understand what is a dual nature? It can act as a wave, it can act as a particle. Have you heard about this term?
Yes, sir.
As a dual nature, it can act as a wave, it can act as a particle, an atom, or an electron. Let us take the example of an electron. An electron is a particle. Particle, when I say in this particular context, quantum theory of light, quanta. Have you heard about this word quanta? Quantum comes from quanta. Let us try to explain what is the difference between a wave and a particle. When I say particles, particles are discrete objects. 1, 2, 3, 1 particle, 2 particle, 3 particles. So they are discrete. They are separate from each other. They are discrete. They are not continuous. Those things are particles. When you think about wave, sine wave, have you heard about sine wave? Cos wave, wave. Any wave is a continuous phenomena. Yes or no?
Yes, sir.
So something, if it is continuous, it's a wave. Something, if it is discrete, it's a particle. For example, steps. You take steps. Are steps waves or are steps particle? One step, you either take one step or you take two steps. You cannot take 1.5 step. Can you take 1.5 step when you are climbing, when you are going to your terrace? Either you are on one step or you are on second step. That's a particle. Got it?
Yes, sir.
But instead of a step, you have a slope like this. You have gone to a railway platform. On railway platform, you have sometimes you have this slope and sometimes you have steps. When it is a slope, it is continuous. Yes or no? You can step anywhere that you feel like. That slope is a wave. But if you have steps, you can only step on first step or the second one or the third one. So steps become particle and slope becomes a wave. Understand the difference?
Yes, sir.
Light has got dual nature because some phenomena can only be explained by particle nature of light. When I say particle nature, we call it the quantum theory of light. The other things can only be explained by wave theory of light, interference, spatially, can only be explained by the wave theory of light. There are some phenomena which can be explained by both. It can be explained by the particle theory of light. It can be explained by the wave theory of light, reflection, refraction, and so on. Therefore, light has dual nature. It has wave nature as well as particle nature. We understand this?
Yes, sir.
In this photoelectric effect, which nature of light is utilized, or how we can explain this photoelectric effect? By which nature of light is this photoelectric effect explained? It's already given. By which nature? By which principle or which theory, with what nature do we explain photoelectric effect? Remember, photoelectric effect cannot be explained by wave theory. Please mark my words. Every word, everything that I say will become a question in the exam. Photoelectric effect cannot be explained by wave theory. It can only be explained by particle theory of light. And that particle theory of light was explained by Einstein in the thing known as quantum theory of light. What do you mean by quantum theory of light? He said, oh, light is not a wave. Light has particle nature. That means light consists of particles. One particle, two particles, three particles, infinite number of particles. What are those particles known as? Which he said that light consists of. Have you heard about? You can call them quanta. One quanta of light. But instead of calling it a quanta, we have a new name for it. Do you know the new name? Light consists of what? Light consists of photons. Have you heard about this term, photons?
Yes, sir.
1 photon, 2 photon, 3 photon, 4 photon, 5 photon. This is particle theory or quantum theory of light. Light is not a continuous thing. Light is not a wave. Light consists of particles. It is like particles. Dum, 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 dum. Those particles are known as?
Photon.
Those particles are known as photons. Now, these photons have energy. These photons have energy. And how much energy a photon has? We'll come to that, but I'm just telling you how much energy a photon has. H multiplied by F. Now, what is this H and what is this F? We will try to understand that. But this is how Einstein explained Einstein explained photoelectric effect by the quantum theory of light. Do we understand this?
Yeah, yes, sir.
Okay, I'll give you a minute to note this down. A minute to note it.
Okay, sir.
Have you noted down, bacha?
Yes, sir.
Good, sir. Aage, let us move aage, sir. So,
Yes.
this is the diagram by which we are trying to explain what happens in a photoelectric effect. A very simple diagram. What do you see here? What are these? These spiral-like things. What are these spiral-like things? This is the light which is falling. And what is this one? This is one thing. This is the other thing. This is the third thing. This is the fourth thing. This is the fifth thing. This is the sixth thing. What are these small one particle? This is a photon. Do we understand this?
Yes, sir.
So light consists of these small particles, photons. Now what is happening? This is a sodium metal, one of the metal which is a photosensitive metal. When these photons or light is falling on this metal, what is going to happen? This photon have an energy HF. What is H? What is F? We'll understand this. Don't worry. When light energy falls on this, radiation falls on this, these are ejected. What are these that are ejected? These are the electrons. These electrons are known as photoelectrons. The effect is known as photoelectric effect, and the current which is established is known as photoelectric current. Is it clear from this diagram?
Yes, sir.
Well done, sir. Then we'll come to understand each and every term. Just giving you a certain outline. This is the experiment that Hertz did. Same thing explained in a experimental setup. Hertz explained this again. Ultraviolet light or radiation is falling on a photosensitive metal. What will happen when this light falls on this photosensitive metal? What will happen? Electrons will be ejected. Yes or no?
Yes, sir.
And then you have a voltage difference applied. This is the negative plate. This is the positive plate. So what will happen to these electrons? These are negatively charged particles. They will move towards the positive side. Yes or no?
Yes, sir.
So we will have a current flowing in the circuit. This current is known as
Photoelectric current.
photoelectric current. This is a simple experiment that tells you how radiation is falling, how electrons are ejected, and how current is established. You don't need to draw this, you just need to see this. You will be given this sheet. You can note this down, only the important formulae. For example, what is the energy of a photon? HF. We'll understand what is H, what is F. Don't worry.
Okay, sir.
Okay, but everything will be there, but you have to note down so that the important points are there with you in a very small space. I'll also send you something known as a mind map. With this mind map, with just one sheet, you will have the entire topic right in front of your eyes. I'll send you that as well. I have seen it, and I'll send you the questions for practice. A simple question over here. Who discovered photoelectric effect?
Heads.
Hertz, not Hertz, Hertz. Don't write Einstein, because if this question comes, everyone will say Einstein, but the answer is not Einstein. You got this?
Yes, sir.
Yes, sir. No, sir. Better I go, sir. Then, sir. This, sir. Planck. Quantum theory. Again, quantum theory was not given by Einstein. It was given by Planck. Planck. And therefore, we have Planck's constant. What is quantum theory of light? He contemplated, he told us, he said to us, what did he say? Ki light is not a wave, but light has got particle nature. Whenever light is there, it has small particles. Energy radiated from a source, which is light, thermal radiation. Radiation is in the form of small packets. Packet of biscuit, packet of anything. Small packets of chocolates. And these packets are known as photons. Small packets, that spiral thing that you saw. Small packets. According to Planck, the energy of a photon is directly proportional to frequency. Do you know what is frequency now? F is the frequency. Do you understand this? The number of oscillations in circular motion. Go back to circular motion. Particle is moving in a circle. The number of revolutions it takes in 1 second is known as frequency. Do you know this?
Yes, sir.
What is the relation between frequency and time period? Do you know this? F is equal to 1 by T. You know this?
Yes, sir.
SI unit of frequency is hertz. Do you know this?
Yes, sir.
Well done, sir. Then you also know the relation between speed of light and frequency. Speed of light and its wavelength. Do you know this?
No, sir.
C is equal to F lambda. Now you know. What is C? Speed of light or speed of any wave. This C is what? Speed of light. Remember this formula, note them down in your book. C is the speed of light or any electromagnetic wave or any wave for that matter. C. Whenever you see C stands for speed of light. What is F here?
Frequency.
Frequency. Well done. What is lambda here?
Wavelength.
Wavelength of light. Light is a wave. Wavelength. Light has particle nature. Yes, but it's also a wave. C is equal to F lambda. This is the formula that you must remember. What did Einstein know? What did Planck tell you? That energy of this wave. No, he was not talking about wave. He was talking about light. Light is a particle. He told me that light consists of small particles called photons, and each photon has an energy. How much energy a photon has? It is directly proportional to its frequency, or I can write the energy of one photon as H multiplied by F. H is known as the Planck's constant because he found out this relation, and therefore H is known as Planck constant. You should remember its value. If a question comes, the value would be given to you. Don't worry about that, but still you must know the value of Planck's constant is 6.62 into 10 raised to the power minus 34 The SI unit is joule seconds. You can also find out its dimension. I will leave that to you. F is the frequency of photon and lambda is the wavelength of the photon. E is the energy of photon. C is the speed of light. Are you now understanding all the terms that are appearing in this formula?
Yes, sir.
E is equal to HF. But I know that C is equal to F lambda. From here I can find the value of F and I can write it as HC by lambda. Do we understand this?
Yes, sir. Speed of
That becomes another formula for energy of a photon. So I can write it this way. Energy of a photon is directly proportional to the frequency. Remember, speed of light is constant. You cannot change the speed of light. Speed of light is constant. H is also a constant, but frequency is different. Energy of this photon is inversely proportional to wavelength. Do we understand this? Less the frequency, more sorry, more the frequency, more is the energy, directly proportional, but less the wavelength, more is the
higher.
energy, inversely proportional. Do we understand this?
Yes, sir.
That is the basic formula. Almost all the questions that you are going to get in this particular topic will be based on this formula. 99% questions. 1% still remains. We will see that. Now, when I have this H, which is 6.62 into something something, and when I have this C, which is 3 into 10 to the power 8 something something, when I multiply this, I'll get some value. Don't have to do it at always. Now remember, there's a shortcut formula for this to find out the energy of a photon. Now, how this formula comes is E is equal to hc by lambda. We have just multiplied them, divided them, and then we have got this formula that energy. Now remember, this energy that we are talking about in this particular chapter or in this entire topic of modern physics, this energy is very small, and it's not very wise to state it in terms of joules, because joules is a very big unit. It's just like stating if I want to understand what is the radius of an atom, which is in Armstrong unit, which is a very small unit. If I start to tell you the radius of an atom in terms of kilometers, kilometer is a very big unit, and the radius of an atom is very small. It will be very difficult and stupid for me to tell you that in terms of kilometers. So what do? I make a smaller unit for that. The smaller unit for energy, which we'll be using in this chapter and from here on, and you must have known this, is electron volts. Do you know this unit, electron volts, EV?
Yes, sir.
How much is one EV equal to? And these are the things that you must remember. One EV, one electron volt, 1.6 into 10 raised to the power minus 19 joules, right?
Yes, sir.
So now the shortcut formula arises. How does the shortcut formula look like? To find out the energy for any question that comes, the wavelength of the photon would be given to you, bacha. The wavelength would be given to you. Can you see this wavelength here? Dung, 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 dung.
Yes, sir.
The wavelength would be given to you. Why it is not coming? Why it is not getting highlighted? So the wavelength would be given to you. You just divide 12,400 by the wavelength, 12,400 by the wavelength, and you will get the energy in electron volts. Will you remember this, the most important formula of this chapter and coming chapters?
Okay, sir.
Get the energy of any photon, any light, any wave, you just divide 12,400 by lambda. But there's also a small thing that you must remember. This lambda has to be in Armstrong units. Do we understand this?
Yes, sir.
How much is one Armstrong unit?
10 to the power of minus 10.
Yes. So convert the wavelength into Armstrong units, and you will have what? You will have the energy
Electron.
of the photon. Do we understand this?
Yes, sir.
Okay, let me see, sir, if I can get you a question based on this. Let me see, the question is here. Okay, the question is here, and I shall show it to you now. Do you see question number 14, bacha? Do you see question number 14, bacha? I will what? I will do this. Ting, 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 ting. Then I'll do this. Ting, 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 ting. And I have this. Ting, 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 ting. Okay. I have this bigger version of the same question. The wavelength of a photon is 4,000 Armstrong units. Calculate its energy. You have some options in front of your eyes. Now, this question could have been easier if the answer was in electron volts. Whatever. Can I expect some answers?
4.95 into 10 to the power of minus 19.
4.95 into 10 to the power minus 19 joules. That is absolutely correct. How did you get it, bacha?
E is equals to 12,400 by wavelength.
Just give me some time. I am not as fast as you guys. So I just put the formula. E is 12,400 divided by lambda. Lambda has to be in Armstrong unit. The good thing is lambda is given in Armstrong unit, so I don't have to do anything. So I just divide it by 4,000. Dung, 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 dung. 20 gone, 20 gone. I just divide it. But this answer will be in which unit? This answer will be in which unit? This answer will be in electron volts. The options are not in electron volts. So what do I do now? I convert electron volts into? I convert electron volts into joules. And how do I convert it? So it is 124 divided by 40, and I have to multiply it by 1.6 into 10 raised to the power minus 19. And if you multiply and divide it, which I know that you are good with, I think you will land up with the answer, and the answer is definitely 4.95 into 10 raised to the power minus 19. Did you all get this, bacha?
Yes, sir.
Everyone in the class got this answer? So you understand the significance of what we have done?
Yes, sir.
This is one of the very favorite questions, and what I'm going to do is I'm going to show you some question probably in what oops, losing connection. Okay, got this now. Let me see if I have a question here. Oops. Not that direct question is not there. I'm looking for a direct question. Direct question is not there in your thing. I don't see a direct question. That's strange. Okay, here is a direct question that I see. So I will just put it out. And this was a question number 54. This was from Banaras Hindu University, BHU, which is not now an IIT, in the year 1997. Do you see question number 54?
Yes, sir.
The energy of a photon of light of wavelength 450 nanometers. It's nanometer, not Armstrong unit. Can I have an answer? 54. Can I have an answer? You have to convert nanometer into Armstrong units. It's very simple. Divide it by, 12,400 divided by Armstrong unit, and you shall have your answers. Can I expect that you will give me an answer, bacha? So all the past questions that have come in PMTs, AIPMT, AIMS, NEET, and all those questions. You know the conversion between nanometers and Armstrong units? Nanometer is 10 to the power minus 9 meters. Armstrong is 10 to the power minus 10. So how much is 450 nanometers? Getting this, or I shall do it?
2.5 into 10 to the power of minus 19.
Okay. I think that would be the correct answer. So how do you do it?
450 nanometer converted into the.
So
into 10 to the
energy
power
is simply 12,400 divided by 450 nanometers. I cannot divide it by nanometers. I have to divide it by the Armstrong unit. So it will be 4,500. Yes or no?
Yes, sir.
This gets cut. This gets cut. This will be the in electron volt. So I just multiply it by 1.6 into 10 to the power minus 19. It's a simple calculation that you can do, and you can get your answer and stay happy. We understand this? Yes or no?
Yes, sir.
Yes, sir. No, sir. Then this question, sir. This is a straightforward question.
Yes, sir.
One more to get your veins pumping. This is Rajasthan PMT. Rajasthan PMT used to be one of the toughest PMTs because there is a lot of competition in Rajasthan. Quota is there. Wavelength of an emitted light from a monochromatic source is 6,000 Armstrong units. What is the energy of the photon? This comes to you right away. This is what I call a straight question, which can be done straightforward. I hope you can give me an answer for this one, bacha. Do you have an answer, bacha?
2.5.
2 or 2.5? That is the only thing that you have to understand here, right? 2 or 2.5? So basically, you just have to calculate it, right? How do you calculate it? Energy is 12,400
by 6,000.
by 6,000. That's it. You just need to divide it. So it is 124 divided by 60. If I take 1 0 off, this is 12.4 divided by 6. And how much is 12.4 divided by 6?
2.6.
2.005 something, na?
Yes, sir.
Or 6 something. So what is the closest to this? 2 is closest, or 2.5 is closest?
2 is closest.
2 is the closest one. So the answer has to be 2 electron volt. Have you understood this, bacha, everyone?
Yes, sir. Yes, sir.
Everyone is confident? Can you all raise hand that
Yes,
we are
sir.
confident how to do this? We have understood the formula and we should be able to calculate the energy. Can I have some raise hand from the class?
Yes, sir. We are.
Okay. Chalo then, we were here. We were here and we have understood. We have understood the question, how to solve it. But we also saw some questions where momentum of the photon was asked. And we can also get question where someone might talk about the mass of a photon. Remember, the rest mass of a photon is 0. Will you remember this?
Yes, sir.
Photon does not exist at rest. It's a hard-working fellow. It only exists when it is moving. And with what speed a photon moves?
Momentum.
Huh? It moves with the speed of light. Yes or no?
Yes, sir.
Don't have any doubt, sir. Pakka, sir.
Yes, sir.
Photons does not like to be rested.
They will move.
It is not the 12th man on a cricket that is resting. He always works. Rest mass.
Always move.
Yes, beta. What did you say?
Sir.
Okay. So the bottom line is, it only exists when it is in motion. So if it has motion, it has some linear momentum, mass into velocity. Yes or no?
Yes, sir.
These are the different formulae. These are the different formulae for that. No matter how you write it, this is the momentum of a photon, E by C, HF by C. Instead of nu, write it as HF by C or H by lambda. From here, you can find out the linear momentum of a photon. P standing for momentum. Three formulas, all are what? All are similar. Yes or no?
Yes, sir.
Do you remember this?
Yes, sir.
Please note them down. These are the formulae for linear momentum of a photon. You may also be asked a question where they ask you what is the effective mass of a photon. Remember, the rest mass is 0. But when it is moving, it has mass because it has momentum, because it has energy. Because of energy comes its momentum. Because of momentum comes its mass. Do we understand this?
Yes, sir.
What is the effective mass of a photon? These are the formulas. I may not explain them. Once you know momentum, you divide momentum by C, you will get the mass. Yes or no?
Yes, sir.
So you can also write it as P by C. Or you can write P as M into C. M standing for mass, C standing for the speed of light. So I can say the effective mass of a photon is inversely proportional to the wavelength of the photon. Please remember these small things will come to you as questions in your examination hall. You got this?
Yes, sir.
Have you noted this down?
1 minute.
Please note it down, bacha.
Completed, sir.
Completed, sir. Then, sir, a small question, sir. Here comes theoretical question. Mass of violet photon and mass of the red photon. Which mass will be more, the violet one or the red one?
Red one.
Wrong answer, dear. Oh, you said red one, na? Yes. Why red one?
It have more wavelength compared to violet.
Yes. Remember VIBGYOR. Don't forget VIBGYOR. You know VIBGYOR?
Yes, sir. Rainbow color.
Rainbow color. This is the smallest wavelength. This is the largest wavelength. Largest wavelength has got the smallest mass in terms of photon. Smallest wavelength has got the largest mass in terms of photon. Do we get this?
Yes, sir.
Dun, dun, dun. Then I saw a question here. There are so many questions here. I saw a question where the momentum of the photon was asked, and here it comes, and we shall now do it. We have already done the next question. Now we will do this one. So I'll just rub this off. And again, it's from IIT-BHU. This is the question. What is the momentum of a photon whose frequency is dung, 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 dung? I'm waiting for your answers. Meanwhile, I'll find out more questions to solve. Anyone with an answer, bacha? Do you know how to do this? Have you noted down the formula that we gave?
We are trying to solve, sir.
Okay. Try. If you want a hint, the hint is here. Tongue, tongue, tongue. This is the hint. 3 different formulas are there right in front of your eyes. No values are given, so you have to remember those values. What is the value of Planck's constant? What is the value of Planck's constant?
6.6 into 10 to the power of minus 34.
That's it. Put the value of that. Put the value of frequency. Put the value of speed of light, and you will end up with your answer. Can I have that? So the momentum P would simply be equal to bacha h by lambda. Is that so?
Yes, sir.
Or I can write it as h c by f or what? So don't get confused with the formula. Please remember that. Do you get it, beta? What was the formula?
Yes, sir.
You'll have to remember all these formulae, because if you just confuse yourself, hf by c was the formula. I have cross-checked it. hf by c. If you just forget the formula, you will end up in a soup. Do we understand this?
Yes, sir.
H is 6.6 something. F is given as 1.5 divided by C, and you will get your answer. What is the answer you are getting now, bacha? You might be having a problem in multiplying. Is that so?
We are poor in mathematics, sir.
Okay. Okay. So, where is the problem? 6.6 into 10 raised to the power minus 34. That is one part. Multiplied by frequency, which is 1.5 into 10 raised to the power how much? 13 divided by the speed of light, 3 into 10 raised to the power 8. So first of all, you can just do this. You can just cut this and you can write 2.2. Yes or no?
Yes, sir.
So you can multiply 2.2 by 1.5. So you will not get this, right? You will not get this. So the only options could be option A or option B. Yes or no?
Yes, sir.
2.2 multiplied by 1.5, you will get 3.3. Yes or no?
Yes, sir.
The only problem is with the whatever is on top of 10. It's very simple. This is 10 raised to the power minus 34. When this 8 comes on the top, it will become minus 8. Yes or no?
Yes, sir.
So minus 34 minus 8 becomes minus 42. Yes or no?
Yes, sir.
Minus 42 plus 13, and you have your answer.
29.
Minus 42 plus 13, you will get minus 29, and that is your answer. Yes or no?
Yes, sir.
The answer is 3.3 into 10 raised to the power minus 29. Do we understand this?
Yes, sir.
That is the correct answer. I hope all of you have done this. Shall we move ahead?
Yes, sir.
Then this is the next question, and you will find many of such questions in your exam which are straightforward. You know this, you don't know this, you just tick and give me the answer. What is the answer for this one? Which of the following is true?
A.
And that is correct. Do we understand this?
Yes, sir.
As you can see, things are pretty damn simple. If you understand them, they are pretty damn simple. One more question here. Come see. The questions are pretty straightforward in this chapter. This is CPMT. Previously it was CPMT. Your NEET was CPMT. Which of the following statements are true about which? Remember the question. Is incorrect. Oops. Incorrect. Do we understand incorrect?
Yes, sir.
Not correct, but incorrect.
Photon can't exist pressure.
Photon can't exert pressure. That is correct. But that is incorrect, right? Photon do exert pressure. So that is the answer for this one. Are we getting the hang of things? What type of question comes?
Yes, sir.
Bakka sir. Let me see if I have. If I have. If I have more questions so that I can let you know what type of questions you can expect.
Sir, what is the answer for 41?
Yes, that is D, beta. You are correct.
Yes, sir.
You are
Okay,
correct. Don't worry. If you are not correct, I will correct you.
Okay, sir.
I will correct you. Okay, this is from the Wala part, so I'll just skip it. Looking for a question where you have. Okay, all the other questions are. See, what type of questions you get? Look at this question. Question number 9. Do you see question number 9?
Yes, sir.
Straightforward question. This came in AIPMT. AIPMT is your NEET. So, the moral of the story is the questions are pretty straightforward. If you understand them, you understand this. Okay, I'm done with the questions here. There is no question that we can do right now. Have you seen this effective mass of the photon and the...
Yes, sir.
Don't forget this, because everything that we do will become a question in your paper, and then you will have to solve that question. Remember that. Now we come to a somewhat difficult thing to understand. If a question comes, then it might take some calculations here. And here we are talking about something known as intensity of light. Have you heard this term, intensity of light? Intensity of light or any wave. So this is also a part of your wave optics or your ray optics. What is the intensity of light? When I talk about intensity of light, it is denoted by the letter I. It is the energy falling per unit area per unit time. Will you remember this? Energy per unit area per unit time. So if I say this is a body, energy is falling onto it. Let us say 5 joules of energy is falling on it. 5 joules of total energy is falling on it. If I divide it by the area of this body, and if I divide it by how much time that energy is falling, the quantity that I will get will be known as the intensity. Energy divided by area divided by how much time that energy is falling. Do we understand this?
Yes, sir.
That is known as the intensity. So my intensity I becomes energy E per unit area A per unit time T. Intensity becomes E divided by AT. From here I can find out the unit of intensity. The unit of energy is joules. Remember this. Units and dimension. 1 question, 2 question will definitely come from here. The unit of area is meter square. The unit of time is second. So it becomes joules per meter square second. Do we understand this?
Yes, sir.
But if you look at this term E and if you look at this term T, energy divided by time, energy per unit time. Does energy per unit time ring a bell? What is energy per unit time? Does it remind you of something? Nothing? Energy per unit time. Energy per unit time. Rate at which energy is falling. Rate at which energy is given. Work, power, energy. Do you remember anything?
Yes, sir.
What, sir? Tell me, sir. This is power. Energy per unit time is power divided by area. Do we understand this, bacha?
Yes, sir.
Yes, sir. No, sir. Yes, sir. We understand this, sir. So I can also
Understood.
write intensity as power divided by area. Hence, we have watt divided by meter square. Do we understand this?
Yes, sir.
P standing for power of the source, A standing for area, T for the time, E for energy. Do we understand these terms up till now here?
Yes, sir.
Now, now, how is this energy falling? Now remember, the name of this chapter is photoelectric effect. So this energy will be falling in, light will be falling on it. Any radiation is light. Light will be falling on it. And what does light consist of? Bacha, in this chapter, what
Photon.
does light consist of? Photons. So
Photon.
basically what I'm saying is photons are falling onto it. Yes or no?
Yes, sir.
What is the energy of one photon?
1.6.
Arey? The energy of one photon is H multiplied by F. Yes or no?
Yes, yes, sir.
Energy of one photon is H multiplied by F.
HF.
How will I find the total energy which is falling on this body? Large number of photons are falling on this body. How will I find the total energy falling on this body?
HF by area.
Huh? I will multiply. I will multiply what? Energy of one photon. I write energy of one photon. How much is the energy of one photon? Tell me, bacha.
HF.
HF. So what will be the total energy? E. Capital N multiplied by HF. What does capital N stand for here?
Power of
Huh?
photons.
It is the number of photons which are falling in time t. Are we getting a sense of what we are talking here?
Number
So
of photons incident.
energy is falling in terms of photons. I multiply the energy of one photon by the number of photons and I'll get the total energy falling. Yes or no?
Yes, sir.
So how does the formula look like now? Does it look like this? Intensity I becomes N into H into F divided by A into T. Yes or no?
Yes, sir.
That is the next formula that you must remember. Intensity is N into H into F divided by A into T. Will you remember this?
Yes, sir.
Now, sometimes instead of giving you the total number of photons which are falling, remember, instead of giving you the total number of electrons, total number of photons which are falling, which is capital N, they give you small n. What is this small n?
Number of photons per second.
Number of photons per
Per
second.
second.
So that means it is n, capital N divided by T. In that case, bacha, your formula becomes N into HF, small n into HF divided by A. Do you remember this? Do you understand this? Can I have some reason that we understand this?
Yes, sir.
Small n into H into F divided by A. I'll give you a minute to note down everything that we have discussed till now.
Okay, sir.
Till now. Take a moment. So if you can understand this, we are done with the most difficult part of this chapter. Meanwhile, I will search for some questions that I can give to trouble you.
Sir, completed.
Sir, completed.
Sir, when we are getting this booklet of this chapter, of this topic.
I've already sent it to you. You should be getting it. I'll talk to sir and I'll ask him to give it to you ASAP. Do you understand the meaning of ASAP?
As soon as possible.
As possible. I'll make sure that you get it ASAP, and I hope that ASAP comes today. Okay.
Okay.
So with that booklet, what you will have is you will have all the questions, and if you can only do, it has 3 exercises: level 1, level 2, level 3. Don't go for level 1, don't go for level 3. Only do questions from level
2, 3.
Which has got, I think, around 85, 87 questions, and all those questions are from previous years. And this NEET wala people, they are very lazy. They don't make new questions. What do?
Repeated questions.
They just repeat the questions.
Yes, sir.
So we'll only do questions which have already come. Do we understand this? Because that covers everything that has come up till now. Because there cannot be anything new, right?
Yes, sir.
The only thing they can do sometimes when they give you numerical from 6,000 Armstrong, they will change to 3,000 Armstrong. That is the only creativity they have. They are very not creative people. So why to do all those questions? Why do you 150? We have around 80, 90 questions. We have less time and we have to do more work. So we do smart work. That's how we do smart work. Okay. Comes the next part, and this is where most of the questions are likely to come. So from equation, we can just find out from this equation or from the other equation, we can just find out. What we can find out is the number of photons which are emitted per second. And I may not explain this. The number of photons which are emitted can be found out by variety of ways. You can find it by P, which is the power, divided by H into F. Or you can substitute the value of F and write it as C by lambda. So you have the formula for number of photons. Number of photons will be P lambda by HC or P divided by HF. Remember this is capital P, and capital P stands for power. Do we understand this?
Yes, sir.
So they have now created a dabba, and this dabba gives you a multiplied version. Because here I have H into C. We know the value of H, we know the value of C. So you can remember this value of 1 divided by HC, and this 1 divided by HC is 5 into 10 to the power 12.
24.
NEET is all about how fast you can do things. And that is why you remember all these things. So the formula of number of photons falling per second becomes now very simple. It was very simple in the very first case, but now I have also put the values, and it becomes 5 into 10 to the power 12, 24 multiplied by P, which is the power, multiplied by lambda, which is your wavelength in meters. Remember, we are talking about the SI unit. Do you understand this? Yes or no?
Yes, sir.
Yes, sir. No, sir. Then, sir, this is the question from your IIPMT, sir. I'll give you a minute to solve it. Any answer, sir, from this one, sir? You already know the formula, sir. Yes, sir. No, sir. The formula is here, sir. The shortcut is only for lambda, so we can't use that shortcut. We can also use a shortcut. We can put lambda c is equal to f lambda, so you can put the value of lambda. You can get the answer straight away. Yes or no? Why are you taking so much time, bacha? Maths is kamjor. Multiplication division is not maths. You don't call multiplication division and maths. It is similar to saying A, B, C, D as English. If you know A, B, C, D, you know English? No. That is the basics. You must know it. So multiplication and division and multiplication and division and addition and subtraction is not maths. This is basics. Can't forget basics. You can't forget A, B, C, D. In Hindi, it is A, E, E. I'm sure it would be something in Telugu. I don't know. So, whatever. PA, do we have answers here? Yes, sir. No, sir. I don't have answers, sir. Too much time. Okay. Shall I do it?
Sir.
Yes, sir. Number of photons. What are we supposed to find out? Number of photons per unit time. Yes or no?
Sir.
So that is 5 into 10 raised to the power 24. How much is the power given? Power is given as 2 into 10 raised to the power minus 3. Yes or no? Yes or no?
Sir.
Multiplied by lambda. How much is lambda? C divided by F. Yes or no?
Sir.
C is 3 into 10 raised to the power 8. C is a simple multiplication, bacha. Divided by the frequency. How much is the frequency? 6 into 14. How long you will take to calculate this? It is a simple calculation. Tongue, tongue, tongue. And you have the answer, tongue. What is the answer? This will become minus 24. Minus 24 plus 24 becomes 10. 10 minus 3 becomes 7. 7 plus 8 becomes 15. So your answer is 15. And that is your answer. Do we understand this?
Yes, sir.
Why it was taking so long, sir? It should not take this long. It is simple multiplication division, bacha. Can't
Okay.
take so much time to solve this. Chalo, I wish you all the best for the next one. And the next one, again, as I told you, the only creativity they have is just changing the values. And this is the creativity that they've shown from 2007 to 2009. Just change the values and then I can ask you the same question. Chalo. Can you do better this time? Monochromatic light of wavelength falana falana is produced by a helium neon laser. The power emitted is this 9 milliwatt, I guess. It cannot be micro because micro is written by mu, so it should be milli. The number of photons arriving per second on the average at a target is rated by this beam is how much? I'm waiting for your answers, my dear friends. They've given 667 because they want to cut this 667 from that 6.6 of H Planck's constant. Do we understand this? That's why 667. Waiting for your answers, gentlemen and ladies and everyone.
Three into 10 to power of 16.
Yes, bacha.
3 into 10 to power of 16.
3 into 10 raised to the power 16. That is correct. Everyone got this answer? Yes or no? Can I have some raise hand that we got the answer?
Yes, sir.
Everyone, girls, I don't see your hands.
I want to.
Got your answers? How you got to do this? You can just put the formula straight away. Power is given, wavelength is given. You can use any of the formula. You can use the shortcut version. Here is the shortcut version, or here is the long cut version. Whatever version you use. Here, I think using the long cut version would be better because N can be written as power P. How much was the power P? Array. Power P was 9 millivolts. So 9 into 10 raised to the power minus 3 multiplied by 667 nanometers. So 667 into 10 raised to the power 7. Remember,
Yes, sir.
nanometers, so minus 9, sorry, divided by Planck's constant is 6.67. So this will get cancelled, multiplied by 10 raised to the power minus 34, multiplied by 3 into 10 raised to the power 8. Now it is a simple question. You can easily solve it. Yes or no?
Yes, sir.
So that is how you get your answers. Anyone got this?
Yes, sir.
That was all about intensity that you must know. Okay?
Okay, sir.
Shall we move ahead with the next and the last topic, probably last thing that we'll do today? Well, again, now the question, now the topic that is there might be a difficult one because hardly seen a question on this type. But again, I must tell you, if this question comes, very few people would be able to solve this. So it's given in your sheet. What I'm trying to do here is explain what is happening here. We got a question in the previous years that, which option is not correct. And the option that was not correct was photons do not exert pressure. And the correct thing is they do exert pressure. So you now see, how do they exert pressure? This is one gentleman, one photon which is falling on a particle on a sheet. Yes or no? Do you see the sheet?
Yes, sir.
What happens? Three things can happen. The sheet can absorb it, absorption. Sheet can reflect it, reflection. It's a wave. Absorption, reflection, or refraction, transmission. Yes or no?
Yes, sir.
What is happening here is we are just taking one example. We are not assuming that it is getting absorbed. We are not assuming that it is getting transmitted or refracted. It is only getting what?
Reflection.
Reflected. So it strikes with a momentum h by lambda. Do we understand the momentum h by lambda? We have already seen the formula for momentum. Yes or no?
Yes, sir.
So momentum is a vector. So if I take this as positive, this becomes negative. Yes or no?
Yes, sir.
So the final momentum is minus h by lambda.
Yes, sir.
So how much is the change in momentum? H by lambda minus h by lambda. So it becomes 2h by lambda. Yes or no?
Yes, sir.
But that is the momentum of one photon. One photon is not falling. A large number of photons is falling. N number of photons are falling. Yes or no?
Yes, sir.
So the total change in momentum becomes 2nh by lambda. Any doubts on this one?
No, sir.
This is the next formula that you will do when it is falling on a perfectly reflecting surface. Do we understand the heading? Please note down the formula. Perfectly reflecting surface. Just write the heading. Force on perfectly reflecting surface. You may not draw the diagram. The diagram is already there in your sheet. Save some time. You just write the final answer that you get, and that is 2nh by lambda. Am I clear?
Yes, sir.
I'll give you a minute to ponder your thoughts. Okay, so this is one way of finding out the momentum. See, remember, understand, NEET is not about your knowledge. It is about how fast you can give that knowledge, and in where different ways you can write the same formula. Yes or no? Do we understand this?
Yes, sir.
Same formula can be written in different ways. The more the number of ways you remember, the faster you can solve the question in the examination hall, and more marks you are likely to score. Because I guess I know that the most time consuming of the all four subjects that you have, PCMB, PCBZ, physics, chemistry, biology, physics, chemistry, botany and zoology, physics is the toughest of these. Yes or no?
Yes, sir.
The more the number of ways in which you can remember a simple formula, single formula, because sometimes they'll give you that, sometimes they will give you this. If you know how to make the khichdi out of it, you will be saving a lot of time. Have you written this? Yes or no?
Written, sir.
Written, sir. Then, sir. This, sir. What, sir? This, sir. See, I just divided by the time. I will get force. Yes or no? So this becomes the first formula of force. Do we understand this?
Yes, sir. Divided by time.
This becomes the first formula of force. I just divided by T. This becomes the second formula of force, 2P by C. Do we understand this? Second formula for force. Where P stands for the power and C stands for the speed of light. Do we understand this?
Yes, sir.
Yes, sir. No, sir. Then you can have a formula for pressure as well. These are the two different ways in which you can write the formula of pressure. I'll give you a minute to note it down. And these formulas are not arriving from sky. Pressure is force divided by area. I just divided by the area and written it in different forms. Nothing else. I have not done anything extravagant. Just remember the formula, put it, stay happy.
Okay,
I'll give
sir.
you a minute to note this down. This is perfectly reflecting surface. Do we understand this? Remember, they will give you a question. They will specify whether it's a perfectly reflecting or something else. That something else is coming right now. If you understand one formula, you would be able to write all the formulas just by looking at, okay, is it perfectly reflecting or is it perfectly something else? Have you done this formula now?
Yes, sir. Written.
Yes, sir. No, sir. Then I go, sir, and I come to this this one where you have a perfectly absorbing surface. What will be the difference between a perfectly reflecting and perfectly absorbing? Tell me, bacha.
Absorbing it will take total force in it. It totally
Ah.
absorbs the force. Absorbs the photon totally.
So, in first case, the formula for force was 2P by C. Here it becomes only 1P divided by C. Do we understand the difference?
Yes, sir.
Yes, sir. Then please note it, sir. And similarly for pressure, it becomes I divided by C. Do we understand this?
Yes, sir.
Yes, sir. Please note it, sir. This is the formula for a perfectly absorbing surface. Power becomes P by C. In the previous case, it was 2P by C. Now it has become P by C. Pressure was 2I by C. Here it becomes I by C. Written it down?
Yes, sir. Completed, sir.
Completed, sir. Good, sir. Then, sir, this, sir. Sometimes, just to make the question more difficult, what will they do? They will give you the angle of incidence as theta. It is not falling like this perpendicularly. It is falling at an angle theta. Yes or no?
Yes, sir.
What do you do then? You just put a cos theta in between. Got it?
Okay, sir.
So if it is a perfectly reflecting surface, it becomes 2 times. If it is a perfectly absorbing surface, it becomes
Single.
single. The 2 becomes single. Perfectly absorbing, 2 disappears. Perfectly reflecting, 2 appears. Now, if you remember this formula, bacha, that pressure is 2I cos theta divided by C. Now you can put the value of theta differently and you will get different answers. For example, theta is 0 becomes the case where it is falling perpendicularly. Yes or no?
Yes, sir.
Cos theta, when theta is 0 becomes 1. So your answer becomes 2I by C. Yes or no?
Yes, sir.
So now if you just remember this formula, you don't have to remember the other two. You got this? Yes or no?
Yes, sir.
Golden key points. We come to these golden key points. The point that you must remember, because there could be a question straight away from these golden key points, and the golden key points are very simple. Rest mass of a photon is 0. We have already seen that ultraviolet light causes photoelectric effect emission from any metal surface, while visible light causes photo emission from alkali metals. Which one has more energy, ultraviolet light or visible light? Another question. Yes or no? Who has more energy, ultraviolet or visible or infrared?
Yes, sir.
Rank them in terms of energy. Who will have more energy? Ultraviolet, U, visible, V, infrared, R. Which will have the most energy? Are?
Red.
Red has the most energy. Why?
Bigger wavelength.
Which has the most wavelength?
Sir.
Which has the longest wavelength?
Longest wavelength. R.
Longest wavelength is R. Energy is directly proportional to wavelength. Yes or no?
Yes, sir.
Energy is directly proportional to wavelength. Yes or no?
Energy is inversely proportional.
Energy is inversely proportional. So tell me, bacha, which will have the most energy? U means ultraviolet, V means visible, R means infrared. Which will have more energy? Ultraviolet will have more energy compared to visible, and visible will have more energy compared to radius, compared to infrared. Whether you talk about frequency or you talk about energy, energy is directly proportional to frequency. Energy is inversely proportional to frequency. Energy is directly proportional to frequency. Do we understand this? And energy is inversely proportional to wavelength. Do we understand this? So ultraviolet light will have more energy compared to visible. Visible will have more energy compared to infrared, and therefore ultraviolet light can cause photoelectric emission from any metal surface because it has more energy, whereas visible light only causes it from alkali metals because alkali metals require less energy for photoelectric effect. Do we understand this?
Yes, sir.
All these are questions that are going to come in your exam, and when it comes, please not leave them, because these are straightforward questions. I'll wind up this class here at this point in time. The next class, we shall move ahead. I hope that you have enjoyed this class. There are a number of questions given here, example number 1 and example number 2. I'm sure that you can do this. Calculate the energy of a photon of this wavelength. You can easily calculate this. Then you have to find out number of photons emitted per second. Remember, all the questions that have come in your CPMT or your NEET or your AIMS are based upon only these two examples. Yes or no?
Yes, sir.
If you do these two examples, you have done all the questions. So you may not do the entire exercise. You can just do the solid example and you are done.
Okay,
Because the rest of the questions are just different variations of these two questions. So I leave it at this point. I hope you have enjoyed this class. I'll meet you tomorrow, same time, same day. Not same day, different day, same time. See you. Have a nice day. Take care. Bye bye.
Okay, sir. Bye. Take care, sir.
Take care.